Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 5.4, day 1, entitled More Trigonometric Graphs. And today we're going to talk about mostly the tangent and the cotangent graphs. Okay. We'll also talk about the cosecant and the secant, but we're just going to do tangent and cotangent for today. We'll save secant and cosecant for tomorrow. And as we're talking about the tangent and the cotangent, we'll also talk about some of the transformations that happen to them as well. So again, that's all the stuff we've been talking about with amplitude and period and phase shift. Okay? All right, so if we're graphing the tangent and the cotangent functions, see if I can get that out of there. Okay. We have to remember that sine and cosine both have a period of 2 pi. And the tangent and cotangent then are going to have a period of pi. Why does that keep popping up? Okay, so keep in mind that since the cosecant and the secant are going to be inverses of the sine and the cosine, they'll also have a period of 2 pi. But again, we're not dealing with that today. That's just kind of a review of sine and cosine and then a hint of what's coming up in the next section. So today we're just going to focus on the tangent and the cotangent, and they both have periods of pi. Okay, so basically what I want to do first is just show you what the tangent function actually looks like if we kind of build it from scratch. Okay. So let's make a table of values for tangent. And we're going to say that tangent is equal to sine divided by cosine. Okay, so sine of x divided by cosine of x. So if I've got my x, it's going to be a big table, and then my y values. Okay, so I'm going to have my x and my y values, and I'm going to start at 0. Now, remember, tangent is going to be sine over cosine, so you want your unit circle, you want your terminal points as we go around the unit circle. Okay, so if I'm starting at 0, then my sine and my cosine values are going to be 0 over 1, so that's just going to be 0. And then if I do pi over 6, okay, I'll end up with the square root of 3 over 3 when I simplify everything. And that I'm going to write as a decimal. That's going to be 0.58. That'll be easier to put on the graph than square root 3 over 3. Okay. The pi over 4, that's going to be the square root 2 over 2 and the square root 2 over 2. So that's going to be 1. At pi over 3, okay, if I'm dealing with sine over cosine, then when I simplify that all the way down, I'm going to end up with the square root of 3, which is going to be 1.73. And then at pi over 2, okay, the terminal point there is 0 and then 1. So that actually ends up being 1, 0 when I do sine over cosine. So that is undefined. If it's 1 over 0, that's undefined. And then I go around to 2 pi over 3. That would be my next section. And that, when I take my terminal point and I do the sine over cosine and simplify everything down, that's going to end up being a negative square root 3. So that'll be a negative 1.73. And then I'll have 3 pi over 4. And that is going to end up being a negative 1. 5 pi over 6. Okay, when I simplify that terminal point, I put the sine and then the cosine over each other and simplify. I'm going to get negative square root 3 over 3, so that's going to be negative 0.58. And then at pi, that terminal point is going to be negative 1, 0. So if I do sine over cosine, that's 0 over negative 1, so that's going to be 0. And I'm going to go all the way until I get to negative pi over 2. I think that'll be good enough. We'll be able to see our pattern developing here. Okay, so my next increment would be 7 pi over 6. Okay, then if I take that terminal point and put the sine value over the cosine value, simplify, I'm going to get that square root 3 over 3 again, which is the 0.58. And then at 5 pi over 4, that'll be a 1 again. And then for 4 pi over 3, I'm going to get the 1.73, which is really the square root of 3. And then at 3 pi over 2, that again would be my undefined value, because I'd be over 0. And now keep in mind that negative pi over 2 is the same as 3 pi over 2. We're going to be seeing negative pi over 2 a lot. So just keep in mind that that's the same as negative 3 pi over 2. I'm sorry, 3 pi over 2. Okay. So now I'm going to plot some of these points on my graph here, and I'll plot them in a little bit different colors so we can see them. So I'm starting at 0, 0, and then at pi over 6, pi over 6 is going to be really close. I'm going to have 0.5. Let's just say it's kind of about in there. Pi over 4 is right here. That's going to be 1. And then pi over 3, not quite a half, but that's going to be 1.73. It's right about there. And then at the half, it's undefined. So when that happens, my graph doesn't exist. My function doesn't exist there at pi over 2. Okay. And then at 2 pi over 3, I'm at negative 1.73. So maybe down here. And then at 3 pi over 4, I'm at negative 1. And then at 5 pi over 6, I'm at negative a half, roughly. And then at pi, I'm at 0. And then I'm at 0.5. 5 pi over 4, I'm at 1. And then 4 pi over 3, I'm at 1.73. And then at 3 pi over 2, it doesn't exist. Okay. Now, if I connect these points, I don't really connect them in a straight line. I know it looks like it's kind of diagonal, but what's actually going on here is that we get this curve that goes like that. That's what the tangent function actually looks like. And I could extend, I have parts of another curve here, so I could kind of do the half and the whole, and then the little bit more. I'd have another asymptote here. So this part of the graph would go like that. And I could start another curve over here. Okay, I don't have the rest of the graph drawn in there to be super duper precise, but that's, you know, what it would look like if I extended it over some more. Okay, so notice that at pi over 2 and at negative pi over 2, those were the values where the graph didn't exist. So those are my vertical asymptotes. Okay, and remember that those vertical asymptotes is where the denominator is going to equal 0. Now, if we're dealing with tangent, remember tangent is equal to sine over cosine. So anytime cosine is equal to 0, that's when my denominator is going to be 0. So cosine is going to be 0 here at 0, 1. and 0, -1. Remember, in our ordered pair, cosine comes first. So this value is pi over 2, and this value, well, it's 3 pi over 2, but remember, that's also negative pi over 2. We're going to be seeing it written that way a lot more. Okay? So that's why at pi over 2 and at negative pi over 2, our graph didn't exist. Here's pi over 2. There's negative pi over 2. There's 3 pi over 2. That's where our vertical asymptotes are because that's where we get 0 in our denominator. That's where we had these little dashes in our table of values showing that the graph doesn't exist at that point. It's undefined. Okay? So you have to think about that now as we're doing these other more complicated graphs with tangent and cotangent and then secant and cosecant. You have to think, where does the function exist or not exist? And that's going to help you know where those asymptotes are. Okay? So for the tangent and the cotangent, we're going to have vertical asymptotes. So here's a much nicer graph of the tangent function. That's basically what it looks like. Okay, again, notice they have their vertical asymptotes drawn in with these little dashed lines, so you're going to do that on your graphs as well. And then here's a picture where they're repeating. Okay, they've made 3 periods of it. And notice that the period is pi. To go from negative pi over 2 to pi over 2, that's a distance of pi. To go from pi over 2 to 3 pi over 2, that's a distance of pi. Okay, so every pi, you have one of these little swoopies, I guess you could call it, one of those tangent curves. So you could keep this graph going in either direction, and you could have as many of those tangent curves or those little swoops as you wanted to have. Now remember that the tangent curve starts low. It starts in the negative values, in the negative y values, and then it becomes positive as it goes to the right. So from left to right, it goes from the negative and then goes through 0 and then up to the positive. Okay. So now we're going to do basically the same thing for the cotangents. Okay. Except now we're going to do cosine divided by sine. Okay. So this I'll do a little bit faster because we already get the idea for how to make our table of values. Okay. So we have x, and we have y. So we're going to start at 0. Now, the terminal point for 0, for cotangent, remember, I'm doing cosine over sine. Okay, so this would be 1 over 0 then. So this is going to be undefined. And at pi over 6, I take that terminal point. I have cosine over sine. So I have the square root 3 over 2 over 1/2. So that would be the square root of 3. So that's 1.73. At pi over 4, I would end up with 1. Square root 2 over 2 and square root 2 over 2. At pi over 3, I would end up with the square root of 3 over 3 when I simplified everything down. So I get the 0.58 again. Now, notice that that's kind of the opposite of what we had before. I'm going to go back to a moment to our tangent graph. Our first few values here, we had 0, and then we had the 0.58, and then the 1, and then the 1.73. Now I have undefined 1.73, 1, and then 0.58. Okay, so we're starting with bigger values and we're dropping as we're going around the unit circle here. So then at pi over 2, I would end up with 0 over 1, which is 0. At 2 pi over 3, I would end up with the negative square root 3 over 3. So that's negative 0.58. At 3 pi over 4, if I take that terminal point and do the cosine over sine, I'm going to end up with negative 1. And then 5 pi over 6. Okay, there again, I'd find that terminal point, do the cosine value over the sine value. So I would get the negative square root 3 when I simplified that. So negative 1.73. And then at pi, I get another undefined value. Okay. So if I went to graph this, I'm going to stop there on my table of values because this is enough to see what the graph looks like. Okay, 0 is undefined, so that's where one of my asymptotes is going to be. And then at pi over 6, I'm going to have 1.73. Pi over 4 is 1. Pi over 3 is going to be 0.58, so maybe right about there. Pi over 2 is going to be 0. And then I have my negatives, -1, -1.73. Then it's undefined again. So if I connect those, this is what the curve for a cotangent function would look like. So again, the period is pi. We go from 0 to pi. It's very similar to the tangent, okay? Except notice that it's shifted and it's going in the opposite direction. So my first asymptote for a cotangent function was at 0 instead of being at -pi over 2. And the end behavior is opposite from tangent to cotangent. Okay, so I could extend this if I wanted to. I could put in another asymptote at 2 pi, and then halfway between pi and 2 pi is 1.5 pi or 3 pi over 2. So then this would be where my next little swoop would go. And I could reverse it going the other way. I could put another asymptote at pi over 2, or I'm sorry, -pi, and then at -pi over 2, that would be my midpoint. So that's where the little swoop would cut through the x-axis. Okay, so that's a more precise book version of what the graph would look like. And there's multiple periods that have been drawn. Okay, so now that we know those basic behaviors and those basic shapes of what the tangent and the cotangent functions look like, now we've got to talk about some of those transformations that can happen to it. And this is still the same transformations that we've dealt with the sine and the cosine graphs. We're still going to have an amplitude, so we'll still have an A in front of the tangent or the cotangent. It's not really going to affect our graphs a whole lot. When you're graphing the tangent and the cotangent, we can be a little more loose, I guess I should say, with where we put our ordered pairs. We don't have to be super duper precise. We're just going to kind of draw in the little curves. So just keep in mind that if it's a whole number, it's going to stretch it taller. If it's a fraction, it's going to kind of smush it down. So that is the effect I want to see in your graph. I'm not worried so much about actually knowing how much it stretches it. Okay? We're still going to have a k value, and that k value is going to affect our period. So we'll be taking pi and dividing it by k, and that's how we'll get the period for each of these tangent and cotangent graphs. And then we're not really going to have a shift so much, a phase shift like we did for the sine and the cosine, but we are still going to have this x minus b, or the k times x minus b. And that is going to actually be our vertical asymptotes. Okay, I'll show you how to use that information to help you find where your asymptotes go. So it'll make graphing it a lot easier. Okay, so this is just the basic function. I like the way it's written on this page a little bit better because they have the x minus b value in there. Okay, and again, remember that our period is going to be pi divided by k. All right, now when you're making your tangent and your cotangent graphs, you have to know where those vertical asymptotes are going to be, and you have to find what we call consecutive vertical asymptotes. Now, on a quiz or a test, we might just say, find the consecutive vertical asymptotes. Find 2 of them, find 3 of them, find 5 of them, okay? And here's how you do that. For a tangent graph, remember, tangent has vertical asymptotes at pi over 2 and at 3 pi over 2. or negative pi over 2, because that's where the function doesn't exist. Okay, so we're going to take that k times x minus b, that same stuff that we did for a phase shift for the sine and cosine function, but now we're going to set it equal to negative pi over 2 and pi over 2. So that's traditionally where our asymptotes are supposed to be, but now they might shift a little bit depending on the k values and what's being added and subtracted to the b. Okay. And then for the cotangent function, okay, we're going to take that same k times x minus b value, except we're going to set it equal to 0 and pi. It's because that's where the cotangent function is undefined. That's where those vertical asymptotes are. Okay? So knowing where the denominator is 0, knowing where the function is undefined, that determines these values right here. The cotangent function is undefined at 0 and pi, so that's what you set those phase shifty type of expressions to, that k times x minus b. Okay? And the tangent function is undefined at negative pi over 2, which is the same as 3 pi over 2, and pi over 2. So that's why we're setting these equations equal to negative pi over 2 and pi over 2 for tangent. So there is some remembering that you have to do here. Now that we've got two more types of graphs, there's different details for the sine and cosine graphs than there are for tangent and cotangent. So you have to keep all these little details straight in your mind. But you should be able to think through it as well, knowing where is my graph undefined. If you know where it's undefined, then you will know where to set these equal to, or what to set those equations equal to. Okay, so my example 2 has a part A and a part B. They're both going to be tangent graphs, and then in example 3, we'll do a cotangent one. Okay, so this is pretty basic. Tangent of 2x. Okay, now we don't really need to write down the amplitude. Like I said, amplitude is going to tell us how stretched and tall or how smooshed and compressed the actual curve is going to look. But we don't really have to focus on it too much when we're drawing our graph. Okay, so we can write it down. The amplitude would be 1, or the absolute value of 1, which is 1. Okay, there's nothing out in front of that tangent there. Okay, so if you write that down, that's great, but for this graph, it doesn't really help us a whole lot. We still need our period, just like we did for the sine and the cosine. So now, though, since it's tangent, remember, it's pi divided by k. And my k value is that 2 right there. So pi over 2. So every pi over 2, I'm going to get a new tangent curve. Now, the other thing I have to figure out is where my phase shifts are going to be. And the phase shifts, how we were thinking of that for the sine and the cosine function, is really now what we're going to think of as our vertical asymptotes. So that phase shift concept for sine and cosine, we're going to think of that now like vertical asymptotes for tangent and cotangent. Okay? And so what we're going to do is we're going to take this whole 2x value and we're going to set it equal to the values where a tangent function is undefined. And remember, those are negative pi over 2 and pi over 2. Okay? So then I'm going to solve this for x. So I divide by the 2. So that's going to get me negative pi over 4. So there's my first vertical asymptote. And then if I solve that for x and divide by 2, I'll get pi over 4. So there's my other vertical asymptote. So that's what I want to put in my graph first. Okay. So I'm going to do negative pi over 4 and then pi over 4. Okay. Now I know that it's going to be a tangent function. I know that tangent starts in the negatives, and then as it goes from left to right, it comes up into the positives. My amplitude is 1, so I don't have to worry about making it stretched more or shrunken down. Okay, so I'm just going to try and draw a tangent curve then in, and I have to make sure that I'm going through the x-axis in the middle of this period. So halfway between negative pi over 4 and pi over 4, that's 0. So I have to make sure that my graph and my curve, when I draw it in, goes through 0. So there you go. Now there's one period. We can repeat this now. We know that my period's pi over 2, so if I'm at pi over 4, another pi over 2 would be 3 pi over 4. And again, you can do that on your calculator, so you could take pi over 4 plus a half, okay, or take 1/4 plus a half. And then again, draw in another tangent curve. And if you want to go the other direction, you can. Put in another asymptote, and then draw in another curve. Okay? So the nice thing about these is that you don't have to make a table of values. So that's nice, but there is a lot of detail to remember with the vertical asymptotes and what you set it equal to. Okay? Okay, so let's try another one. Tangent of 2 times x minus pi over 4. Okay, so again, I could say that I have an amplitude of 1, or the absolute value of 1, which is 1, since there's a 1 out in front. My period is going to be pi divided by that k value, which is 2. So pi over 2 is going to be my period. And then I have to do my shifting, my phase shifting, which is really my vertical asymptotes. Okay, so my first vertical asymptote then, I'm going to take this whole stuff, this whole thing, 2 times x minus pi over 4, and I'm going to set it equal to negative pi over 2. And then I'm also going to set it equal to a positive pi over 2. And again, I'm setting it equal to negative pi over 2 and pi over 2 because that's where a tangent function is undefined. Okay, if tangent is sine over cosine, cosine is 0 at pi over 2 and negative pi over 2. Remember, negative pi over 2 is 3 pi over 2. Okay, so then I'm going to solve these for x. So I'll divide by 2 on both sides. So then I get x minus pi over 4 equals negative pi over 4. And then I add the pi over 4 over, so that's going to be 0. Divide by 2, so x minus pi over 4 equals, again, pi over 4. And I add the pi over 4, so now I get pi over 4 plus pi over 4. That's going to be 1/2, or pi over 2. So now I have shifted where my vertical asymptotes are. I have one at 0, and I have one at pi over 2. Okay, so the traditional tangent graph has a vertical asymptote um, at pi over 2. Okay, that one's okay. Let's go back here and look. That was cotangent. Doot, doot, doot. There's our tangent. Okay, so we normally have them, there we go, at negative pi over 2 and at pi over 2. Okay, so this graph has shifted a little bit. Okay, I've kind of shrunken the period. So I still have this asymptote at the pi over 2, but now since I've shrunken my period in half, the other asymptote is going to be at 0. Or you could add in another one at pi, which we will in a moment. Okay. Notice that your period is pi over 2. To go from 0 to pi over 2 is pi over 2. Okay, so our period is correct, and we've got it shown correctly in our graph. It's a tangent graph that I'm going to put in now. I'm going to put in that tangent curve. So I have to go from 0 to pi over 2, and I've got to hit that halfway point, which is going to be pi over 4. So I start in the negatives, and I come up, I go through that halfway point, and then I go up to the positives. And I don't have to worry about making this graph stretched or shrunken at all because my amplitude was 1. So you can just draw in a nice general curve and then repeat it. Do another period of the graph. So I have my next consecutive vertical asymptote would be another pi over 2 away. So pi over 2 plus pi over 2 is pi. And then you put your halfway point there, which would be at 3 pi over 4. And then draw in your curve. Okay, so there's 2 periods. That's what you would have to do on a quiz. If you wanted to make it go the other direction, if you didn't want your periods to go to the right, you could make them go the left. So go back another pi over 2. Put in your halfway point at pi over 4, negative pi over 4, and then draw in your curve. Okay, so there's 3 periods of the tangent curve. Okay, so there's the nice, pretty book pictures. A little bit better than mine. Remember, though, that here we have our asymptote at the 0. They don't really show that very well, but it would be there. Okay. All right, last one then is a cotangent. We're going to do the same stuff. We're going to see if there's an amplitude, period. We'll do our vertical asymptotes. And then when we draw it now, instead of drawing the curve going from the negatives to the positives as we go from left to right, these curves are going to go from the positives to the negatives as we go from left to right. So you basically just flip the tangent curve upside down. Okay. Now, technically for this one, you could rewrite it if you wanted to. Since our k value is this 3, we could take out a GCF. We could take out that 3 and write it x minus, now if I have pi over 2 that I'm dividing by 3, that would be pi over 6. Okay, so if you wanted to rewrite the function like that, you could. That helps you see how much the graph is going to get shifted. Everything is going to get shifted to the right, pi over 6 from the standard cotangent curve. Okay? But we'd still have an amplitude. This time our amplitude would be the absolute value of 2, which is 2. So we want to stretch these just a little bit. Our period would still be pi, but we have to divide it by that k value, which our k value is 3. So our period is going to be pi over 3. And then if I want to find my vertical asymptotes, I have to take all that stuff that comes after the cotangent. So that 3x minus pi over 2, I have to take that and set it equal to, now there's different values now for the cotangent. Okay, cotangent isn't sine over cosine like the tangent one was. It's cosine over sine. And sine is undefined at 0 and pi. Okay, we're going to get an undefined value because sine is 0 at 0 and at pi. So that makes the cotangent undefined at 0 and at pi. Okay, so again, you have to think about what's in the denominator there. So now if I solve this for x, I'll have 3x equals pi over 2. And when I divide by 3, I get pi over 6. Here I'm going to add the pi over 2 over. So I'll have 1.5 or 3 halves. And then I'm going to divide by 3. So I'll get x equals pi over 2. Okay, so that's where my asymptotes are going to be. Now, um, this graph might be a little more challenging to do on this type of graph paper, but I'll leave it in here. Pi over 6 is going to be right about here, in between 0 and pi over 4, roughly, somewhere in there. And then, let's see, pi over 2, that's on here. Okay, so there's my asymptotes. Now, I have to find that halfway point between pi over 6 and pi over 2. Okay, I don't want you to just estimate it on the graph and say, oh, it's right about there. I want you to be precise and I want you to label it. Okay, because technically that's an intercept. Okay, that's an x-intercept. So how you do that is, I hope you would be able to figure this out, but this larger value here is 1/2. Pi over 2 is 1/2. The smaller value for the asymptote is 1/6, or pi over 6. Okay, so I need to take 1/2 minus 1/6 to figure out the distance between the two of them, and that's a third. And then I need halfway between that, so I need a third divided by 2, so that's a sixth. Okay, so that means that from 1/6 I'd have to go a sixth and then go another sixth to get to the pi over 2. Okay, so if I'm starting at 1 over 6 and I'm adding 1 over 6, that's going to be 2 over 6, which is 1/3. So at pi over 3, then, that's going to be my halfway point. Okay? And now I'm going to draw in my cotangent curve. So I'm going to start in the positives and come down, go through that halfway point, and then go to the negatives. Okay, now we needed to stretch it a little bit. Maybe that looks like it's stretched, maybe not. Again, I'm not going to be real critical on grading that. It's going to be more obvious, like if your amplitude was 5 or 10, that would have a really skinny graph. Or if your amplitude was 1/4, that would come down really, really far and then get really close to the x-axis and then come down sharply. Okay, so an amplitude of 2, try and stretch it just a little. Okay, and then if I want to draw in another period, okay, my period was pi over 3, so from pi over 2 I'd have to add another pi over 3, so that would be 5 pi over 6. So that would be right about in here. It's between 3 over 4 and 1. Okay. And then again, to find my halfway point, I'd have to take 5/6 minus 1/2, and then I'd get 1/3. I'd divide it by 2, I'd get a sixth. Okay, that's good because I was adding a sixth here and adding a sixth here. So I want to keep adding another sixth. Okay, so if I did that, if I did 1/2 plus a sixth, I would get, right about here, I would get 2 pi over 3. So 2 pi over 3 would be that halfway point between those asymptotes. Okay, so there's 2 cycles. If you wanted to make another cycle, you could. We would go back to negative pi over 6. And then this time our halfway point would be 0. So that would be really easy to calculate that halfway point. Okay. So the more you practice this, the more comfortable you'll get with all these little details and what you set them equal to. But remember that for tangent and cotangent, you're going to set them equal, I'm sorry, for tangent, you're going to set the vertical asymptotes equal to negative pi over 2 and pi over 2. And then for cotangent, you're going to set them equal to 0 and pi. Okay. And then remember the directions that they go. And these functions are considered odd. The tangent and the cotangent functions are considered odd because they have opposite end behavior. and that means that one end goes up and one end goes down. Okay, so this is just a little note connecting back to that uh, concept that we've talked about in the past about end behavior of graphs and what makes them even or odd. So homework to practice these concepts is a little choppy, okay, but I've tried to pick out the tangent and the cotangent graphs for you. Definitely practice this. Okay, take a look at the odds in the back of the book. The evens are worked out in the binder in the classroom as well. And if you have questions, come on by and see me before school.